Hello students, welcome to the class, and today we'll complete the part 2 of the second chapter of class 10 science, that is acid, bases and salts. Last day we have completed about the acid and bases, and we have already heard that which properties have the acids and which property have the bases, and how do they difference from between each other. And not only that, the reactions, few of the reactions also we have seen. And after that, how can we measure the acidity or the basicity of a compound or a substance, or what is the pH scale, and what are the measurement of the pH, and which part is the acidic and which part is the basic. So all these things, and what is neutral and what is neutralization, so all this part already we have discussed. Now we will discuss about the salt, that is that is the combination of the acids and bases. We know that acid and bases by reaction, when they combine together, then they form as a new product that is called as salt. As we know that the salt is the table salt that we take for our food. It is not only that, but if you go for the chemical laboratory or the chemistry laboratory, you will observe different type of salts are present over there, which contains the different acids and different bases, and they combine together. And how do they works in different reaction process? Let's see from the next topic, that is known as the more about salt. It means we will read the more few of the topic that is based on the salts. Okay, so whenever we are going for salts, we have to understand that how many type of salts are there. It means we are going in the assembly of the salts, or we can say the family of the salts. Okay, so first of all, we will mention here as a point, that is family of salts. In family of salts, you will observe different salts are present. Few of the examples are given here as a sodium sulfate. Okay, Na2SO4, sodium sulfate. Got it? Next, you can say potassium hydroxide, KOH, potassium hydroxide, because K means potassium and OH means hydroxyl ion. So potassium and hydroxyl ion makes the potassium hydroxide. Next, sodium hydroxide, NaOH. Hydroxide means OH. Okay. Then calcium sulfate, that is CaSO4, calcium and sulfate, both together they mixed and make a salt, that is calcium sulfate. Then we can say that magnesium sulfate, MgSO4, magnesium, Mg and SO4. So such type of chemical formula you must have to learn and must have to keep in memory. You must not forget about it, because it will be needed in the next upcoming chapters. Okay, next we can say about the copper sulfate, that is CuSO4, copper sulfate. Okay, then sodium chloride, NaCl, sodium chloride. So in this way, these are the few of examples what I have given along with its formulae. So not only these huge amount of salts are present in the world, and those which are used in different way. And if you observe the uh, periodic table, okay, Mendeleev's periodic tables, there's also you will observe lots of acids and lots of organic compounds are there. Inorganic compounds names are also there, those which perform to make the salts. So it is the short part of the family of the salt, and which salts are commonly used in our laboratory for making a very few and very simple experiments. These are all. Okay, next we will go for the pH of the salts. It means we have to take out, or you have to observe the pH of different type of salts, those which we have written the name. Okay, Na2SO4. Look, if I take this Na2SO4 and if I go for the back reaction, but it means the reverse reaction. Okay, reverse reaction means which um, uh, which acidic radicals have used and which basic radicals is used in this compound, that is Na2SO4. So easily we can get 2Na plus SO4, 2Na plus SO4, 2 minus. Okay, Na2 plus plus SO4, 2 minus. So in this way we can get the positive and the negative radicals, and this positive and negative radicals, when they combine together, they make the salts. In the same way, if you go for KOH, the reverse reaction, I am taking the reverse reaction of it. then it will come as K plus and OH minus. It means potassium radical and the hydroxyl radical. So in this way, if you go for NaOH, it is quite easy for you to understand. It is Na2 plus OH minus. Okay, so in this way, okay, only one molecule have taken, one unit has taken, so it means Na plus OH minus. In the same way, if you go for MgSO4, MgSO4, here it will be Mg2 plus SO4 2 minus, sulfate always in 2. It is said, or it has taken as a radical by 2. It means Mg2 plus SO4 2 minus. It means whenever two molecules are interchanged together by the valency process, at that very time it becomes as 2 plus and 2 minus means 0. So MgSO4. So such type of salts are made. So these are the reverse reaction process of the salts, and how we get the acid and the basic parts of it, and how do they react to each other. Now if you go for pH balance, if you go for the pH balance, means whether it is neutral or whether this salt is neutral or acidic or basic, we know that the acidic formation will be formed whenever, according to the pH, it will come from 1 to 6, right? 1 to 6 means it will come as the acidic, means acidic property will be shown. And if we go for 8 to 14, then it will show the basic. But what about 7? 7 is always neutral. So whenever we will use the litmus paper, you know that for taking out or for observing the actual acidity or the basic, to find it out, the litmus paper is popular. So if we use on this type of salt, not when the salt is in solid manner, we will not get the proper result from it. So first of all, we have to take the water, and in this water, the water should be the, what to say, it is the actual saturated water. Okay, the actual saturated, it means the cleaned water that is used in the chemical laboratory or the chemistry laboratory. Such type of water is used, and then any of the salt you have to separately mix it in different beaker. So in this beaker, whenever you will mix it, so automatically the salts solution will be made, and in this salt solution, whenever you will put the litmus paper, so easily you will get the result within a quick manner, that is this solution is acidic or basic or neutral. Okay, so in this way we have to find it out the pH balance, and pH balance can be said after making the experiment, not before that. So now I cannot say, but whenever we will go for the experiment in laboratory, then we can get it, or we can get the result finally, that what it will be. Okay, so it is the second process or second part of the salt. So you can see that the salt can be used in different way, and it has also family, it has also the pH, means its color. Next we will go for few of the chemical properties of this common salt. Okay, you know that common salt is also popular in history, because you already read about the Mahatma Gandhi's life, and how did he, along with lots of crowds, he has gone for the Dandi March or Dandi Abhiyan, and there also our table salt was so much popular in our in our history. Okay, in our history of the motherland, because that time also British were not given us the allowance for taking the common salt from the seashore. But as we know that seashore, from there easily through the evaporation of the water, the sea waters converting itself into, it means that the salt form, the salt molecules, those which are present over there, it used to settle down on the sand, and easily we can take it out. So on that free time, it was quite difficult to take, as the country was totally under the British rule. But we have defeated the British rulers, and we have captured our country from themselves. So this is the entire process, this is the historical process that has done in the lifetime of Mahatma Gandhi, and he had to suffer a lot for this only. And now we will go for the chemistry. As we are reading the chemistry, here we will read that how do the salt used to take from, or it has taken from the water or the sea water. We know that in sea water it is salty in taste, and whenever the water is evaporated in a practical manner, then the solid white form, the substances it is formed or it is settled on the container, and it is told as the salt. Okay, sometimes you will observe that whenever for a long time, after a long period of time, when the sea water has dried up in any places, there a very solid type of rocks like salt are present, which contains lots of brown color impurities, or the entire part of the shell of this salt is looks, it looks brown. Okay, those salts are known as the rock salt. Got it? So table salt and rock salt, they are often same, but rock salt contains the impurities, whereas the edible salt or the table salt is quite clear than that of it, and the impurities cannot be seen over there, it is quite white in color. So this is the physical property or the physical feature of the table salt and the rock salt. Now if we go for a few of the reaction process, that how do this salt form, and this type of salt is used, and the byproduct that is coming along with the salt, where it is used, then we have to go for our book. Okay, so first of all, whenever common salt is used as a raw material for different chemicals, then which chemicals are or the materials are being used? It could be as a, you can say, sodium hydroxide, that is NaOH. Okay, NaOH, to produce the NaOH. We know that for producing the NaOH we need NaCl plus H2O, right? NaCl and H2O, when they react together, it means the NaCl salt, when it is poured in, when it is added to the H2O, it means the water, then what it will form? It will form as NaOH solution and Cl2 as an byproduct, or the chlorine gas as byproduct. Okay, and a few amount of, or very low amount of hydrogen gas. So hydrogen gas plus chlorine gas, these are formed as a byproduct along with NaOH. So in this way NaOH are formed with the help of the aqueous solution. We can see here the aqueous solution means the solution by the salt along with the water. As we know that it is liquid, so whenever this NaCl will be poured in the water, so automatically it will make the aqueous solution of NaCl, and it will change itself or recover itself as a NaOH. Okay, so NaOH, it will come in solution form, and Cl2 and H2 will go out as a gas. Okay, now this Cl2 and H2 is used in different way for different kinds of reaction. Now whenever this NaOH or the sodium hydroxide is formed, after that we will produce the product which is known as the bleaching powder. Okay, and the bleaching powder formula is CaOCl Cl, CaOCl, or you can also say CaO in bracket. Oh, okay, no need to give the bracket. CaOCl2, CaOCl2. So in this way also you can write CaOCl in bracket, then Cl, or CaOCl2. It means two molecules of Cl2 or the chlorine. Look, whenever CaOCl or CaOCl2, these are forming, it means chlorine is present, calcium and oxygen. These three components are present together, and they are adjoining together and making the bleaching powder. Okay, so for this purpose, what can we use as a reactants? We have to use here the white slacked lime, that is known as the CaOH2. What is the chemical name of it? Calcium hydroxide. It means the calcium, the lime that contains the water into itself. It means the molecules of water is present with the calcium. That's why it is called the slacked lime. Okay, so this slacked lime, when it is used along with the gas of Cl2, when the gas is passed, when the chlorine gas is passed in the calcium hydroxide solution, it is also the aqueous solution and it is gas. So when this gas is pushing inside this calcium hydroxide solution, automatically the product will form as CaOCl2. It means bleaching powder. Okay, and the water, as we know that it is a aqueous solution, so obviously water will be present over there. Got it? So it means whenever the solution in the solution of calcium hydroxide, chlorine gas is passed, automatically bleaching powder is produced as a main product, and the byproduct water is added with it. So this is the process of taking out the bleaching powder. And what is the use of bleaching powder? If we go normally in our daily life, bleaching powder is used for bleaching the dresses, and to dyeing or the coloring the different type of new clothes, and to impure water to make it pure. It means germ free. Okay, we say na germ free water. There also we use the CaOCl or CaOCl2 or bleaching powder in a very little amount. Got it? Okay, next we will read about the baking soda. Whenever we are seeing the baking soda, what is the chemical name of it? Its chemical name is sodium hydrogen carbonate, or the another name is sodium bicarbonate. Why it is said bicarbonate? Bi means hydrogen. Okay, so sodium, then carbonate, and in the middle there is hydrogen. So hydrogen, sometimes it is said hydrogen carbonate, and sometimes it is said bicarbonate. Okay, so sodium bicarbonate or sodium hydrogen carbonate, both are same. So sodium hydrogen carbonate, it always contains, I am just writing here, 10H2O. What is 10H2O? 10H2O means that 10 molecules of the H2O is being taken by one unit of NaHCO3. It means 1 unit of NaHCO3 means there 10 H2O is present. Okay, not 9, not 11. It means not less than 1, not more than 1. 10 is fixed. So in this way, later we will read after this topic that few of the salts are present where as a crystal, and those salts are in crystalline form. We know that most of the salts are crystalline form. Okay, so how much molecules of the water are kept inside the salts? Okay, we will read on the next topic. So NaCO3 or sodium bicarbonate, it takes 10 molecules of H2O in one unit. Okay, so fine. So whenever we are producing, here is the story of producing a sodium bicarbonate. So how can we produce it? Look, if we just divided this salt, then we will get sodium, we will get hydrogen, and we will get carbon dioxide. Look, so carbon dioxide, hydrogen, and sodium, three properties are present, three different substances are present, those which are coming together or assembled together to make the sodium bicarbonate. And what is present, it means it is aqueous solution. Okay, so let's go for it. Whenever we are going to produce it, we need the reactants as sodium chloride, as sodium is present. So sodium chloride we need it. Next we need CO2 gas. Look, I have told na carbonate, it means carbon dioxide is present. So sodium chloride, carbon dioxide, and we have to take NH3. NH3 solution means ammonia solution. So whenever we are telling ammonia solution, then of course we have to use H2O. Okay, so NaCl, CO2, NH3 solution means H2O. Got it? Now whenever it will assemble together in one beaker, what will happen? From there NH4Cl will form, that is ammonium chloride will form, and our main product, that is NaHCO3. Okay, so NaHCO3, that is the main product, it has already come, and the NH4Cl as a byproduct, it is also present. So it means that commonly you will see that for very few reaction only the main product used to produce. A very few reactions are there, but in most of the reactions, whenever you are going for the reactants and whenever you are going for the combination to make the combine of yourself, so automatically the byproduct will come. Got it? As you have seen over here that CaOCl, Cl and H2O, NaOH, Cl2 and H2. So such type of byproduct will obviously come for most of the reaction processes. Okay, so this is the process how we used to take out the NaHCO3. And NaHCO3 means it is the aqueous solution where per unit how many molecules of water is present? 10, na? So 10 H2O we have to write. So here it is no need to write. Now suppose these we know that baking soda is used for the food purpose, means for making the food, for making the pakoras and cakes and breads. So whenever we are baking, okay, such type of salt, so how does it form itself? As we have told that each salt contains the water into itself, it means whenever we will heat the NaHCO3, okay, with any acids where hydrogen is present, hydrogen molecule is present, it means hydrogen radical we will use here. So NaHCO3 plus H plus, it will come as Na2CO3, it means sodium carbonate. Okay, sodium carbonate it will form, and the byproduct will be CO2 plus H2O. Okay, so they take out as a vapor form the water molecule, as well as the carbon dioxide gas goes out or emitted from this NaHCO3. And this carbon dioxide gas, when it's emitted, automatically the food particles used to puff itself. So that's why the cakes, breads used to puff itself, only due to the process of the reaction by the heating. So heating triangle it we have to give here. So Na2CO3 automatically it has made itself, the compound itself, and carbon dioxide gas evaporated, that's why it is fluffy in looks, and H2 gas also evaporated from there. So this is the process. Now what is the use of the sodium hydrogen carbonate or the sodium bicarbonate? It's quite easy, we have already told that for making the food, for baking the cakes and breads mainly it is used. And as it contains a quite maximum amount of the base into itself, so that's why it is also used as an antacid. Antacid means when the indigestion forms, or when the gastric juices comes out from through our throat, then it feels very uneasy to ourselves. So for that purpose the baking soda can be taken as an antacid. It also gives the relief. Okay, so it's all about this baking soda. Next we will read the washing soda, it means the washing detergent. Okay, so in washing detergent Na2CO3, washing detergent is Na2CO3, it means the Na2CO3 that is formed here, Na2CO3 by giving the heat, it is used, this salt is mainly known as the washing soda. Okay, and this washing soda Na2CO3 plus 10 molecules of H2O. Okay, 10 molecules of H2O, when it takes, then it comes as Na2CO3 comma 10 H2O. It means no reaction used to happens together here. From this topic we could easily understand that the Na2CO3 it is used, this salt is used as a washing detergent, and this washing soda or washing detergent contains each unit or per unit as 10 molecules of the water. Okay, so this is from the washing soda. And this washing soda's uses, we know that it is used in soaps and detergent powder. Okay, and it is also used as borax. So in different purposes it is used. And the removing of the hardness, it means to remove the base, the maximum base from the drinking water, this Na2CO3 is also used. The last topic, that is the, are the crystals of salts really dry? Okay, as I have already told that the salts that is present in different bottles in the chemistry lab, it contains the crystals of the salt. Okay, the crystals of salts. but whenever we looks at it from the outside, it seems that they are totally solid, and there is, we cannot expect the water into themselves, but each salt contains the water in different manner per their unit. Okay, for example, we have already told that Na2CO3, Na2CO3 contains 10H2O. It means Na2CO3, normally it is small crystal looks, but it contains 10H2O. If you evaporate it, then 10H2O will be evaporated, and the Na2CO3 salts will be changed in color. But whenever again you will give the water to itself, then again it will come as its own previous color. Okay, in the same way, if you go for CuSO4, okay, CuSO4, it contains 5 amount of, or 5 molecules of H2O. 1 unit of CuSO4 contains 5 H2O. It means whenever you will evaporate it, so automatically 5 H2O will gives out, or it will be emitted, and this copper will change its color. Okay, it will come as white in color. But whenever again you will add the water along with it, then again it will take its own color, the previous color, it's the blue color. So in this way, each crystals of the salts contains the different amount of the water in each unit of itself. Okay, next, the plaster of Paris. For example, plaster of Paris is given, it is made up of gypsum, we know. So when the gypsum takes 373 Kelvin heat, okay, 373 Kelvin heat, it means 100 degree centigrade. Whenever it comes, or it takes 100 degree centigrade, at that very time it evaporates its water. It means the gypsum salt that contains the water into itself, the water is evaporated or emitted, then it becomes as calcium sulfate and half amount of H2O per unit, half amount of H2O. Got it? And that's why it is said hemihydrate. Okay, half means hemi in chemistry, so hemihydrate, or we can say calcium sulfate hemihydrate. Now if we give the water, so what amount of water it will take, or it will absorb, the gypsum will absorb to reach to its previous position. For that purpose, CaSO4 dot hemihydrate, or half H2O, then it will take 1.5 H2O from the outside, then it will come as CaSO4 2H2O. It means to complete its whole part as 2, it needs 1.5 molecule of H2O per unit. Okay, so that's why per unit it absorbs the half H2, 1.5 H2O with the half H2O, and completes 2 H2O. Then it completes as gypsum again. Okay, so in this way we have to learn more about the salts, and how many percentage, or how many molecules of salts water is present in the salts in the as a crystal. So we can read it well. Now we have to read the topic. The topic is totally completed, the chapter is totally completed. If you read and if you watch my video, hopefully you will understand everything. Thank you so much.